Namaskar, I am Saugat Nepal, Secretary of GSAN, Geomatics Engineering Students Association of Nepal, and your host of this webinar. Me, on the behalf of GSAN, heartily welcome you to this intensive 2 days webinar on exploring OSM data using QGIS. And guys, we are very delighted to see your interest in this webinar, and we will definitely try to give our best to meet your expectation. Now, I would like to request Mr. Gaurav Parajuli, President of GSAN 6th Executive Committee, to take a seat as Chairman in this program.
Thank you, Saugat.
Now, I'd like to request Dr. Krishna Prasad Bhandari, sir, Director of Center for Space Science and Geomatics Studies, advisor as well as supporter of GSAN, Associate Professor, to take a seat as a chief guest in this program. Similarly, I'd like to request Engineer Saurav Gautam, Regional Ambassador of Youth Mappers and faculty member at Paschimottanchal Campus Pokhara and instructor for this webinar, also to take a seat as a guest in this program.
Thank you, Saugat.
I'd like to request Mr. Ajay Dhakal, President of GSAN 5th Executive Committee, to take a seat as a guest in this program.
Thank you, Saugat.
I'd like to thank all the guests for accepting our invitation and presented here to motivate us. For today's webinar, we have a very intelligent instructor, Engineer Saurav Sir, Regional Ambassador of Youth Mapper, faculty member at Paschimottanchal Campus Pokhara. We are very grateful to have such an intelligent and enthusiastic instructor for this webinar, which is the awaited webinar for all of us. Many of us are already familiar with OSM data and their application, but to make more clear about this, I'd like to invite Mr. Sunil Bhatrai, Vice President of GSAN 6th Executive Committee, to give the presentation on OSM data and its application. Hello, Sunil, are you there? Okay.
Yes, I am here. Am I audible?
Yes, you are.
Yes, thank you, Saugat Didi. Slide. Ako cha?
Ako cha, Sunil.
Today we are going to start our session on OpenStreetMap and its application, and how can we use OpenStreetMap in real field, real application. Before going through this, firstly, we have to be clear about what is OpenStreetMap and why do we use OpenStreetMap. There are different types of mapping software, but why to choose OpenStreetMap, and what are the data that can be used in OpenStreetMap, and what are the real application that have been made till now by the use of OpenStreetMap. We will, I have made a short presentation on this topic. Let's start. What is OpenStreetMap? Yes, OpenStreetMap is a freely editable map of the world. It is one of the editable map where everyone can easily edit in it and add data in it. Similarly, the primary output that is obtained from OSM can be used in secondary purpose, just like building map of a certain area and for different types of humanitarian work and so on. For the, from the primary data that is obtained from OSM can be used in different field. Nowadays, OSM is increasing, the interest towards OSM is increasing. It is because there is no any restriction and the availability of map information is very much easy. So that there is, because of no restriction, there is more attraction towards OSM. This has been seen till the day. And OSM is considered as one of the best example, as a prominent example of volunteer geographic information. There are different types of geographic information, and among them, yes, OSM can be taken as a prominent example of volunteer geographic information. And OpenStreetMap is legally accepted all over the world. It is legal, and it is collaborative and contributory. Yes, everyone can collaborate on it and can give their contribution from their own side. Similarly, it is based on one's knowledge. Yes, I want to give one example. I am living in Dang. Yes, I will upload the data of Dang area because I have knowledge of this area. It is based on same knowledge. As people observe one field and give data on OSM. And it is open source community. There is no any restriction in OpenStreetMap. It is open to all. And we'll continue. Every system runs with one principle. There is also one principle for OpenStreetMap, that is no one knows everything. Everyone knows something. All knowledge resides in humanity. स्कलर लेभीले भनेको कुरालाई एउटा प्रिन्सिपलको रूपमा लिइरहेको छ. OSM has been using this as a key principle. No one knows everything. Everyone knows something. Some different people from different parts of the country give contribution because they know of their locality, but no one can knows everywhere from all over the world. So by collecting the knowledge of people from different nook and corner of the country, the whole data of OSM has been going on fulfilled. And we have most of us are familiar with Google Maps. Yes, here from this slide, we can be clear that what is the difference between OpenStreetMap and Google Map. योबाट हामीलाई मजाले थाहा पाउन सकिन्छ कि there is great difference between OpenStreetMap and Google Maps. In the right side and in left side. In left side there is OpenStreetMap, and in right side there is Google Map. In OpenStreetMap, the data available in a certain area is so much detailed, but same area has less detailed data. There is हामीले यहाँ पनि देख्न सक्छौं लेफ्ट साइडमा कति एउटै एरियामा कति धेरै डाटाहरु देखिरहेको छौं, बिल्डिङ, रोड and many more thingsहरु देखिरहा. Same things in right side, same place, less only few amount of data has been shown. Yes, from this we can be clear that many more data can be obtained from OpenStreetMap than Google Map. It is because there is no any boundary. Yes, anyone can edit, anyone can add data, so that the people from every place can add data, so that the data has been increasing. The data of OSM has been increasing day by day. From this we can be clear that there is some difference between OpenStreetMap and Google Map. Yes, why do we use OpenStreetMap? OpenStreetMap नै किन use गर्ने त? First point is that it is neutral and transparent. Yes, there is no any restriction on it. Some maps are के हुन्छ भने कुनै पनि business oriented something हुन्छ भने it is not like that. It is neutral. It does not give priority to some person, and it is banned to some person. This is not. This is equal to everyone. And second one is free editable map, unavailable in other source provided. It can be freely edit. Yes, you normal people and anyone, we and others as well can edit on it and add data in it. And third one is freedom to reuse, redistribute, and make application from it. Yes, from the data of OSM, using the data of OSM that is obtained from OSM, different types of application has been made. Different types of application has been made. It has not only this, it has been reused in different field, such as making map of certain community, as certain country. Different work has been going on by the use of OSM data, and it is updated maps, as it is highly updated in OpenStreetMap. You can observe in OpenStreetMap that in Google Map the data has not been updated so recently, but in OpenStreetMap we can easily update data, and the data is updating day by day. Free to download. It is free to download, and any software, any application that has been made using the OSM data has been made offline. And one more thing is that it is not for profit organization. It is volunteering. It is not for profit organization. That's why we are using. That's why the use of OpenStreetMap has been made easy. And what kind of data can be obtained, can be got from OpenStreetMap? That is roads, highways, bridges, tunnels. As you can see in the slide easily, there are different types of data you can that is available. That can be food, that can be obtained from OpenStreetMap, administrative boundaries, airport, farmland, and so on. Yes, let's talk today's gist. That is some practical application. What are the practical applications that have been made by the use of OpenStreetMap data? Yes, in Nepal, the earthquake of 2017 2015 Nepal had to face a great earthquake in that year. In that year, OpenStreetMap volunteers from around the world rapidly digitized satellite imagery to provide maps and data to support humanitarian organizations deployed to the affected countries. On the right side, there we can in यो चाहिँ म्याप भनेको KLL ले डिजिटाइज गरिरहेको, KLL द्वारा अर्गनाइज गरेको एउटा सर्टेन एरियामा हामी सर्टेन ठाउँमा बसेर they are going to digitize the earthquake prone area, and the map that is obtained from that digitization. On the left side you can see where the earthquake has greatly affected, that is marked. From this योबाट के थाहा हुन्छ, योबाट के गर्न सकिन्छ त भन्दाखेरि the different organization, humanitarian organization from all over the world, they know that where the people are most suffering from earthquake भन्ने कुरा they can easily know. From the information that is obtained from here, they can योबाट आको information use गरेर तिनीहरुले त्यहाँ राहतको सामानहरु they can provide. Yes, this has been used by the help of OSM data. And furthermore, Bipat portal. How many of us are familiar with Bipat portal? Recently, 14 municipality of Nepal has launched this project. It is one of the disaster information management system of the country. This यो भनेको एउटा नेपालको great achievement नै हो. Recent कुनै ठाउँमा that is disaster के भयो भने that we can get easily informed about it. Such a great platform, such a great portal has also used OpenStreetMap. Exposure image को रूपमा OpenStreetMap लाई नै OpenStreetMap को data लाई नै it has used as the exposure image को रूपमा यसले लिइरहेको छ. Bipat portal has also used OSM data. And COVID-19 responses. Johns Hopkins University has prepared the map of the world showing the corona cases in different countries of the world. I mean, देखिरहन्छौं day by day we are seeing that there are different maps has been prepared by the use of OpenStreetMap, by the OpenStreetMap, and another project. एउटा प्रोजेक्ट चाहिँ के भएको थियो भने OSMले लन्च गरेको चाहिँ मेनी हस्पिटलहरू डिजिटाइज भएको थिए फ्रम द्याट त्यो patient like can easily go to hospital. Where is that? Where is the hospital available from the place where he has lead? Hospital. Then can easily know. This type of work has been made possible by OSM data. And similarly, as you can see here, mobile application. Different types of mobile application have been made by the use of OSM data. Some application like OSM and Maps.me and has been developed using OSM data, which can be used in offline mode. Right? You say offline mode might use गर्न सकिन्छ. Yes, it is in the left side. That is the image that I have screenshot from returning from Pokhara to Tulsipur. In previous when I was not familiar with this application, के हुन्थ्यो भने म चाहिँ कुन ठाउँमा आयो भन्दाखेरि चाहिँ by looking outside, by looking on the board on either of hospital, either of bank, either of hotel, यो ठाउँ आएछ भनेर त्यहाँ लेखेको रिटर्न गरेको थाहा हुन्छ. But अब जुन टाइमदेखि म यो एप्लिकेसन युज गर्न थालेँ, then I open my mobile and I go to OSM or Maps.me, and from that I can get my location where I am. यो के युज हुन्छ भने in most of the area, नेपालमै भन्नुपर्दा पनि यहाँदेखि काठमाडौँ जाँदाखेरि, पोखरा जाँदाखेरि, in different places there is no any network coverage. In some places in that area we cannot use mobile data. हामीले चाहँदा पनि mobile data use गर्न सक्दैनौँ. In that situation we can use this offline map so that we can get our location. This helps in tourism sector, navigation, business sector, and so on. This has been made only possible by the OSM data. And different types of maps has been made of different places. This is the one example of Tulsipur sub-metropolitan city, which has been made by OSM, by the use of OSM data. And we will discuss how to make such types of map on today's session, and we'll discuss many more about it. We will explore further more about it. Okay, thank you.
Thank you so much, dear Sunil. I think now you have a clear idea about the OSM data and their application. So for now, I'd like to request our chief guest of this program, Dr. Krishna Prasad Bhandari sir, to express his words.
Thank you, Saurav Nepal, the Secretary of GISAN. Today's instructor, regional youth member, Ambassador Saurav Gautam, and all the GISAN members and all the participants of this program. And thank you very much giving me as an opportunity to be as a chief guest of this program, and I'm very happy that to give you some few words. And this kind of activities will be very helpful for our students and who are working in geomatics engineering, and GISAN is doing this type of work from the beginning of its establishment, and to give the academic and professional activities to our students. And we are proud of that GISAN, because our student already has participated in many international conference, international workshop, and international seminar. And some of our students is working in AIT now, and they were working as a internship from our university, and we have recommended them. And some of the students, they have been already participated in Wuhan University for the summer schools, and some of our students went to Dehradun in the IRS. And our GISAN, chairman already, have participated in Germany and Africa and Bangladesh and Japan and so many, that international opportunities. And there, not only that international opportunity, most of the students also participating in this type of webinar now after this COVID-19 situation. But before we have, Jishan has conducted the program physically in Pashimansal campus. And so now, Center for Space Science and Geomatics also studies also the, support to you, and we have supported our students through the Nepal, Canada, geomatics student, scholarship, and our students are doing some research, and it is going on, and some has completed, and our student also participated in international conference by doing this research in Malaysia, India, China, and so they are going to, that present in near future, maybe in other, countries. And so this is the golden opportunity to our students now, and to take part in this webinar. And I hope that, and you learn. And this is over. Now we have to think about the open source, that open source software, and you are using, that QGIS and OpenStreet mapping. And we are also going to conduct our own OpenStreet mapping, project in Annapurna rural municipality, and the Marek is going to help us in this regard, and Sunil also taking the initiation of these activities. And recently, I have made, our alumni, and that Prabhat Paudel, and he's going to take some responsibility to do this. And I hope this webinar will helpful for this kind of, that activities in the near futures. And you will join in our, open street mapping. I mean street mapping, especially street mapping of Annapurna rural municipality. And I would like to, if this pandemic is over, and then we can go physically and to take some data verifications in Annapurna rural municipality. And I hope I would like to, I wish for your success and of this program of 2 days, and you will learn so many things from this webinar, and that you can apply in your daily life and in your professional life, or in your research life. And thank you very much.
Thank you so much, sir, for picking us up the time from your tight schedule, and this means a lot to us. And thank you very much. For now, I'd like to invite Mr. Gaurav Parajali, President of GSAN 6 Executive Committee and Chairman of this program, to express a few words.
Thank you, Saurav. Our chief guest, Dr. Krishna Prasad Bhandari sir, our guest, and all the participants. I'd like to welcome everyone to this program. This session named Exploring OSM Data Using QGIS. Hope you all are fine in this pandemic. So, as you all know, we have conducted various programs related to OSM, that is mapping using ID editor, JOSM, etc. We are so much familiar with the mapping in OSM, but we might not have been able to use the data that has been produced using OSM. So today we are organizing this program so that everyone can get an idea on using the data of OSM to create a meaningful information. So we'll be using QGIS platform, where we'll import OSM data and create a map using it. We have our instructor, regional ambassador and faculty member at Pashimansal campus, Engineer Saurav Gautam sir, will be guiding us throughout this session. I would like to thank sir for your valuable time and effort to for this program. At last, I hope everyone will be benefited through this session and find this session useful. Once again, thank you everyone for being part of this program. Thank you.
Thank you, Gaurav. As you know, this webinar is for 2 days, so I'm going to tell you that will you learn within these 2 days. You guys will know the basic introduction of QGIS, GUI, and tools, downloading OSM data, importing OSM data to QGIS, importing area of interest, creating different layers from OSM data within an area of interest like school, health center, roads, location, symbolization, data, map layout, and export. So now, without any delay, I'd like to invite today's instructor, engineer Saurav Gautam sir, regional ambassador of Heat Mappers and faculty member at Pastimansu campus. Sir, now virtual platform is all yours.
Thank you. Thank you so much, Sogat. So, before I'd like to begin, I just want to know that how many of you are quite familiar with OSM and its tools. Okay, so leave that. So can you hear me and can you see my screen? Whatever I'm saying?
Yes, sir.
Okay, cool. Right. So thank you so much, everyone, for joining in this session. And I will try my best to discuss and explore a few things that you might not have been knowing, or you might not have been using about OpenStreetMap, and then also a little bit introduction about QGIS today. What is it, and how can we use QGIS to display and to explore data, as well as in tomorrow's session we will be using QGIS furthermore to explore the data that we download today. So I hope all of you are sitting in front of your laptops and you have downloaded, you have already downloaded the softwares as well. And so this is the agenda of our program for today. We will talk a little bit about the OSM data structure, data model, or data type, whatever you say. And we will try to explore the OSM data using our browser, as well as downloading the OSM data through our QGIS software that we have. And then for tomorrow, we will be preparing a simple layout by using QGIS. So before I like to begin, I would say, so what is, what is your level on OSM? So if you are a beginner, if you haven't known anything about OSM, please write like unfamiliar. And if you are a beginner into OSM, please write I'm only beginner. And if you are intermediate level on OSM, you know the different data types and you know how to download the data, then you are an intermediate level user. And if you like to tweak things around OSM and contributing back to the community, please write you are an advanced user. So I'd like to say again, if you are unfamiliar about OSM, please write in the chat box unfamiliar. If you are contributing a little bit into OSM and you are beginning your journey, please write beginner. And if you are using data sometimes, so please write intermediate. And if you know how to tweak things around, please write advanced. So this just give me idea about what is your level and what things that I have to cover. And as we know that we are from different backgrounds, right? We are from different places and different backgrounds. Also feel free to write where are you from and what are expectations from the program as well. So I can see a lot of you are beginner, some of you are intermediate, right? Okay, I see a lot of you are beginner here. Okay, cool. Yeah. Okay. Yeah, so most of you are beginner, right? So, okay, I hope it will be interesting to see what OSM has to offer. Okay, most of you are beginner. Right. So if someone of you are from different background, if you are from computer science, if you are from geography, if you are from disaster management, urban planning, I think most of us are from geomatics here. So if you are from different background, if you are from IT or any other background, please feel free to write that as well, because I expect most of you are from geomatics background, so I already know that. If you are from any other different discipline, please feel free to write so that we can cover different data points, different types of features that you might need in your field. Okay, thank you. Right. Mhm. So most of you are beginner into OSM. I think I would like to give you a quick overview of what the website is and how can we use the website. So this is how the website looks. Okay, I'm going to hide this. Please let me know if my screen is not showing in any moment. So this is how the OSM website is. So this is a projection that OSM uses and how you see the world in OSM, right? So a few lines, the ocean and the names of different countries that they have preferred to use in their own native language. So I don't know why. Okay, so Nepal and India is not showing. So if we increase the zoom level, we can see, right? We can see the different features in different colors. So this is our main map, right? And then we have an edit option. The edit option, it gives us to edit our map. But when we want to edit, we have to go to a certain zoom level so that we don't use the whole data OSM because it might get very heavy and it might load your system. So we have two options to edit on the map, and if we use the browser, you will be taken into few guiding steps on how to edit with the browser. And this is another handy tool which is called JOSM, and it is used to edit the OSM in offline mode. And then we have a history, right? Because it is an open source map that Sunil had previously told in his platform, and it is different than the Google map we have been using. And since it is open source, every edits can be seen, right? So just before a few seconds, who made an edit on what portion of the world. So we can see those edit history by going through this history. And then there is another button, which is export button. And so this export button lets us to export the area of our map, right? So we can go wherever we want. We can select the area, whatever area we would like to select. And so it will give us it will just give us all those files on the area in .osm format. Okay, so when you export this extent, right? So this is given in latitude, decimal degrees, latitude and longitude in terms of decimal degree. So when you use this export tab, you will just get a file in .osm format. Okay, so this is what we will do later on. Before that, I will show you all the few features of this map. And then we have GPS traces. So GPS traces are those, if you want to publicly add a trace in your of the file that you have used using your mobile GPS or handheld GPS, you can upload that file over here, and it will be used as a guiding object to map things around here. Because at the beginning, so you can see in some part of few areas there is nothing, right? So whenever someone goes to this area and then he also takes a GPS trace of this area and then uploads in on the servers, right? So another person can download the GPS trace and use it as a guiding artifact or guiding element to draw whatever there it is. So obviously the person will get help from the satellite imagery, but the item from the field is very valuable in this case. So you can upload your GPS trace here, and you can also write what your experience using OSM and whatever tool you have developed using OSM uh, on these user diary sections, as well as you can read the user diaries of other people and how they are using OSM on different walks of life. So so if someone is interested about copyright issues, making their own map or any other, using it in a project that you have to address the copyright issues, you can read about here. And there is a help file as well. So when we click help, it will gives us different beginner guides and different ways through you can explore OSM. There are mailing list of various places, right? If you are in a different country, you can find the mailing list of your country, and then it will it is just like an email thread. So you can talk with other users from the country, and then you can share what are your experiences, and if there is something wrong happening with the map, or if you like to add the map or use the map in a different way, you can just talk about the people of your place or your country over the mailing list. We have different forums, we have different IRC chat groups, we have um, the source for different organizations, beginner guides, and help forum as well. So this will take you to getting help. So when you click on help on this button, so there is another about OSM, which gives all those things about what is the movement and how. So the different things about the journey of OSM, its legal uses, and the provisions for open data. So, and there it is your user profile, right? So your picture, your username comes over here, your messages, your profile, and different settings can be seen on the map. Okay, so back to the map. So on this map, there are different colors, different symbols, and different pictures. Okay, so if you want to know about what different object they are and what are their significance, so you can just click on this eye icon, which is for map key, and so by tiling this color with this, I know that this is an airport terminal, right? So it gives us the values of different colors, and you can see whatever is on the map. So you can zoom in using this plus button, or you can just use the wheel of your mouse, or use the plus button of your keyboard, plus and minus to zoom in. It will show you your location that is provided by the internet, and it shows the different layers of OSM. That is standard layer, cycle layers, right? Cycle OSM, transport map, and the humanitarian layers, etc. And then there is another place where you can share this display, right? So if you want someone to meet you in this junction, you can just include a marker, put it over here, and then share this, copy this URL, right? And then share to your friend via email or social media and whatever. So you can also download this screen as an image, right? So if you are using, if you are a graphic designer, or if you are hosting an event and you want to show your place where the event is being hosted, or you just want to use the image, you can download this image into different formats, right? So there is a PNG format, there is JPEG, there is SVG, and there is PDF so that you can use on different applications. So, and then there comes the map notes. These map notes are usually uploaded by the people who do not contribute to the map directly, but they just want other people to know that this feature is not on the map. So this is so that's the function of the map nodes. And then what happens is there are different features on the map, right? So these are the different features. There are different elements that have been combined, and you don't know the name of this, right? So I think there is a restaurant over there, but you don't know what restaurant it is. So there is a very handy tool which is called query feature, and you can see what that element is. So if you hover over this place, it will show you that this is a bank, and this bank is called Tourism Development Bank. This building, and the building, and that the name of that restaurant is New Bablung Saraswati Khazagar. So when you use this query feature, you will know more detail about the place and what is on the map there. So okay, so this is how different data are stored in OSM. And then I would like to switch on to my slide, and I will like to talk a few things about the OSM data model. So what is this? Okay, so this is just from the template. Okay, OSM data model. In OSM data model, so if you are using GIS, right? So what are the different data models in GIS? So can someone write on the chat the GIS data model? Okay, nice. We have someone from forestry, and we have Fatima from marine sciences. Okay, great. So what are the GIS data models, right? Point, line, and polygon. That's the vector. Okay, vector, raster, team. Okay, hello, Ice. Okay, Ice is my friend. Yeah. Okay, yeah. So we have different data models, especially vector and raster data models. We also have tin data model as well, right? But mostly we have familiar with vector and raster in GIS. Okay, so they are the different data models that we have been using and we use in GIS. Okay, so whenever we go through this OSM, um, so what is this, right? This is a raster or a vector. Can someone tell me the display, whatever that you are seeing on a screen, is that a raster or a vector? Okay. So yeah. Mhm. Vector. Okay. Okay. Anyone? Anybody? You think that this is a raster? Okay. So can you see the screen properly? Okay, uh, I want more answers, right? What is this that you are currently seeing, viewing on your screen? Is this a raster or is this a vector? What is this? Mhm. Okay. Okay. Most of you are saying this is okay. Yeah, this get interesting, right? Some of you are saying it's a vector, and most of you are saying a raster. Someone is vector is a raster image, is a vector. Hmm. Okay, so what is the answer, right? Okay, so there is this thing, right? So both of you are correct. Okay, so this is raster also, but and this is a vector also. Okay, so I can show you the both raster and vector on this image, right? So what I can do is I can prove this is a raster in the same time and vector also in the same time. Okay, so can someone tell me they are seeing these lines, right? I don't know. We didn't get to use, we were not used to seeing these tiles or these lines in OSM before. But what I can see now is I can decipher a few lines and we can actually display different tiles in this layer. Can someone see it is a different tiles, there are lines and boxes? Can someone see that? Uh-huh. Right, so it will be more clear over here, right? I can see a line over here. Okay, so this interface, okay, so this interface right here, this interface and this interface, what happens is it is actually a, so when I do this while loading, different tiles had to load, right? So this is a collection of different tiles. Okay, so different tiles have to load, right? You can see different boxes loading on. So it's actually the collection of the tiles here. This map is displayed as a vector. No, displayed as a raster. So tiles, these all tiles are raster. Okay, but the data that the map is using. Okay, so when I go over here and when I go on the layers tab and then show you the map data. Okay, so when I go on the layers tab and display the map data, so what happens is actually it shows us the underlying data contained in OSM. Okay, so when I click on this map data, you can see how this is formed. Okay, so what actually give rise to this map layout, right? So, and I have to use this hand very slowly so that it will click on some objects. So it was a building which was prepared by our dear friend Marek, which is a very active contributor of Nepal, and he's from Poland. And then all these layers, right? So I can click on this house. This building might be drawn by another user. So okay, she also happens to be my friend. Okay, so this is drawn by Nisha. I think it was what? How many years ago? I don't know. 5 years ago, maybe. Okay, so this is this is drawn by Roshan, right? This is also uh, he's also one of our brother, and it was drawn 5 years ago. So the main motive that I'm trying to say is when the map data, it is in vector format. Okay, so this map data, this underlying map data is in vector format, and it comprises of points, lines, and polygons, right? So this element here. Okay, so when you go in and click on this is actually a waste basket. Okay, so it has a tag, right? So this is a point, and this point has a tag. Okay, so this is a vector data, it is a point. So most of you have written about points, line, and polygons, and this is a point, and it has a tag, right? So the tag on that point is amenity equals to west underscore basket, right? Okay, this point has a tag called amenity key. This is a key, and this is a value. And tags are usually key. Tags are keys and value, key and value pairs. And we have another temple over here, which is Hanumanji temple, and this has different tags, right? So this has 4 tags all over, and it has amenity equals to place of worship, name is equal to Hanumanji Mandir, the name in Nepali is in this Devanagari script, right? So, and then we also have a religion, key and value of religion, and it is Hindu. Okay, so I would like to show you this polygon over here. So when I click on this polygon, what it will show? So this polygon is actually a pitch, right? So it is a basketball court, and it has a laser equals to pitch. I'm actually having a very heavy rainfall in my area, so there may be some disturbance in the noise. Please excuse me with that. So this is a polygon, right? So we already saw the tags on different points, and then we have a polygon over here. This polygon has tags, 4 different tags, and the key is laser, and the value given is pitch. Okay, so we also have another tag which is sport, and it is for basketball, right? Okay, so let's see another one. What is this? Oh, so this is it might be one building. So let's see what this is. In this relation, this is a part of one relation, and it was changed by Stadia. Cardia. Let's see what it will show. So this is a laser stadium, right? So this is what? It is a laser. It has a tag called laser, and it is a stadium. And the name of stadium is it's Pokhara Rangasala at Pokhara Stadium. Okay? So what we explored in this is the different data types that we have on OSM. And what is this? This is a highway, and this highway is used as a service lane inside the stadium. Okay, so when we come out from the stadium, we can see another highway over here, right? So when I click on map data, and then when I click on this tab, so this line, what I can see is this is a highway and this is a trunk, right? So it is the main highway, and it has been assigned as highway equals to trunk, and we also have the name of the highway and different tags that has been assigned with the highway. Okay, so let me click on another element. So this is a bridge, right? So there is a river underneath, and this is a bridge, and so different tags of the bridge are bridge equals to yes, highway, on the bridge we have a highway running through the bridge, and that is a trunk highway, which is a very biggest highway. We have layer equals to 1. This layer means the feature is above the ground level, right? So for the ground level, we don't have to write level equals to 0. Okay, so for the ground objects, everyone has layer equals to 0, right? So the river that is flowing on the ground, and it has level 0, but we don't have to write. But if something is underneath the ground, right? So if there is something like tunnel or canal which is going underneath the ground surface, and you have to write level as -1. But if something is above ground level, you have to write the layer, and the layer level is 1 here, right? So it is above the ground level. So this layer is 1. And then we have name of the bridge. It is Seti bridge. In Nepali language, it has name is Seti Pul, and we have the highway reference number, and we have the surface type. So these are the tags that have been assigned with this bridge. Okay, so what happens when we have different tags? So because the bridge is above the ground level, so there is a line, right? You can see a black line, which is black line on the side of the bridge. The part which is bridge, it has a black line over there. It shows that this is above ground level. Okay, so this is how we can see different data and different data layers on OSM, right? So I hope you guys have your QGIS open up, okay? And let me just go back to my slide. So as I said, OSM data, every element on OSM is assigned with a tag. Okay, it's just like going to a supermarket and exploring about what that object is. So if you see a tag on a supermarket, what it shows that it shows the name of the product, and it also gives you an idea about the price of the product. Okay, so on OSM, what a tag does is it gives you the key, right? So it gives you the key on which category the product falls, and then it gives you the value, right? So the value provides in the detailed key specific feature, okay? So what we saw before on the examples was we saw a waste basket, we saw a sports ground, we saw a stadium, we saw different highways, right? So those are all tags that are associated with OSM data, right? So, and then we have key and value pair, okay? So the tag is expressed as a key and value pair, and it is given, it is by the key and value pair are separated using this equal sign, okay? So key equals value, and that is a tag. So when the key equals some value, only the elements will have certain tag, and if it has a proper tagging, it is then only a proper element on OpenStreetMap. So now let's go to the next session. So next chapter of today's session. And then the first approach, we will be downloading OSM data. So you feel free to download whatever data do you like to download, and on for the area of your choice, I will just randomly go few places, or I will just go to those places that I have always been exploring about. So the first thing we do today is we will query the OSM data using Overpass Turbo. So you already know about the tags on
Excuse me,
OSM,
sir.
and okay, yes.
Hello. Sorry for interrupting you. Here is a hand raise of Kishore Paneru.
Okay, so I would also like to say you another thing. If you have any questions, so you can also use this Google Doc to write about your questions here. Okay, so do I have Kishore? Kishore, do you have any question? So he has left the
Sorry, sir.
meeting.
Yeah, left the meeting.
Okay, so if you have any questions or if you have any remarks, please feel free to write on the Google Doc. Okay, so please write your name and where are you from, and please write your question or any remarks over there. Okay, so let's continue with our session today. So the first thing that today we will do is we will use the Overpass Turbo website or Overpass Turbo API to query different features on OSM, right? So let's go. So for that, I have to see, I'll press Overpass Turbo, or you can just go on Overpass Turbo on Google. It will show you result of Overpass Turbo website. So the website is overpass on -turbo.eu, and if you click on the website, it will Okay, so it will, for if you're opening the website for the first time, you see, when you open the website for the first time, it will roam. But I think previously I had used this query, so it just directs me back to my last query. So what I have done previously was I have searched for highway equals to path on certain area, that is Dolpa. So that was my previous query, but let's see that I am doing a research on different uh, hospitals and clinics that are available on Pokhara. Okay, so this is Pokhara, and so for today's program, what I'm doing is I am querying different hospitals and clinics and pharmacies that is related to health facilities uh, around Pokhara, right, in and around Pokhara. So when you go on this Overpass Turbo website, what you see usually is you see different tabs over here. Okay, so this is a run. So that means that it will run this query. So right, it is just like using your using a program editor, right? You're using a code editor. So this is a code, and when you click and run, it will just run whatever code it is on here. So you can also share your code or share your query using this button, right? And it will just what it will do is it will just show this map now, right? But I don't have any query or result shown over there, so I will not share this now. And what I can do is export. Okay, so I talked about export on OSM, the map. Also, we will just go back there and we will see how to export map from OSM also. But this is quite different than the export that we have on OSM. Okay, so if we, while using this export, we will have different options to download the data on different formats, right? So it will just give us different option to download data on various formats. So these are the different data formats that we can export. Unfortunately, we don't have save file over here, but what we can do is we can download either on GeoJSON, GPX, KML, and then later convert it into ASRI save file. So we also have an option to save our query. So if you are using that query frequently, you can save the query over here, and you also can load the query, right? So this is one query that I have saved previously, and I can load the query. And I think you can also log in through your OSM account and then also log out by your OSM account. So there is a help file which gives you example of how different queries are done, right? So yeah, let me, so this is Pokhara city, right? So this is a Pokhara city, and what I want to do is I want to query hospitals. Okay, so I think entity equals to hospital is the right word for the right word, and I think I will build and run query. I'm just checking if the query is right or not. Let me do this again, build and run query. That is not the right key, amenity equal to hospital. And I think my spelling is wrong, I guess. So let's build and run query again. Okay, yeah, so now what we can see is on this bounding box, right? So these are the places around Pokhara. And then especially in this bounding box, what I can see is different features, right? So what I told you previously was OSM data models has 3 data types. Okay, so it is a vector data model, and it has nodes, it has node, it has way, and it has relation. Okay, so if we go over there, so this is probably a relation. It is a relation, right? So we have different polygons and different objects unified as one relation. So this is a relation. This is also a relation because you can see the map key over here. So I think if we read over this, we will obviously know. Ways are shown as blue bold lines, right? So ways would be on blue and bold lines. Polygons are yellow areas within a thin blue outline. Okay, so these are the polygons. And POIs is yellow circles with a thin blue outline, circles with a red filling stand for polygons, right? So these are the different keys or different ways to show different objects, okay? So pink lines or outline mean that the object is a part of at least one relation, right? So if there is a pink line, the pink outline is here, so it means that there is at least one relation. And then we have this, uh, what is this? This is a point, and then it is shown in, right? So it is a yellow, and it is on, it is yellow circle with blue outline. Okay, so there is another object. So this is yellow with a blue outline as well, and it is a polygon, right? So it is another object. So these are the different hospitals around Pokhara, right? So I used the simple query features on a bounding box to do a query of hospitals in Pokhara. So let me do the query again without using this bounding box. Okay, so I will refresh this object. I don't want to use the bounding box. I will just click in this wizard and I will do it like amenity equals to hospital in Pokhara. So what I'm doing now is I am using this in, right? So I want to search what different hospitals are inside Pokhara. So I'm using a query, and what I'm doing is I am giving it a command to find it in certain specific place, right? So for example, you can use tourism equals to museum in Vienna. So it will show you different museums inside of Vienna, right? So what I'm doing now, and what I'm giving this command is I want what different hospitals are inside the boundary of Pokhara, right? So I will just build and run query, and I will see if this is able to find different hospitals inside Pokhara or not. Okay, so it is able to find those, right? So what I can see on the result is that there are 762 nodes, there are 129 ways, there are ways that make the polygon, and then, okay, no, there are 28 polygons, there are, okay, it is the displayed one, right? And we have 129 ways, and we have 3 relations. Okay, so these are the different things that, these are the associated data points on, or you can say these are certainly GIS data, right? So these are the different GIS data that you can actually use on your map if you want to show the different hospitals around Pokhara. Okay, so when I click over there, I can see a lot of things, right? This is a very detailed edit someone has made.
Excuse me, sir.
So it's Municipal College of Medical Sciences. It's a hospital. It has data actually of teaching, ventilator, X-rays. If someone has something to say, any question or something?
Sir, we have a queries. Hello.
Okay. Yeah. What is your question? Just
So we have a question from here. Can we track moving objects in OSM like ambulance, vehicles, or even people using GPS chip? If so, how can we do that?
So where do you want to track people? Tell me first. just okay, yeah. Just playing with it. Okay, so we don't do, so OSM has not that feature. So we cannot track people. Okay, I'll read the question again. Can we track moving objects? Okay, so yeah. So we don't do that. OSM is actually a base map, right? So it is a map which shows different elements, and It is a free and editable map of the world, and we can use the data from the map. But what you can do is you can yourself, you can track yourself. You can move from certain place, right? So you can track yourself. You can move from certain place, right? So you can move from one place to another place. You can use GPS trace and then learning that GPS trace on OSM. So you can do that, but this does not have features about tracking people, right? So I think it goes different way. But Google Map have been doing that, right? So Google Map or so whenever you go to a certain place and you develop region, so what Google Map does is it shows you how nation, right? So these are the different things that Google Map are providing, but Google Map are actually integrating with people's mobile devices, right? Or the GPS system that people have on their cars or other vehicles, and then they actually integrate that system and then display the density of person on that road, and then give you the uh, give you different options, right? Is using this road going to take me to that place faster enough or not? But in OSM, we don't have that currently now, but I guess few people are developing, but it is like a different thing. Okay, so if you want to do that, right, you can do that. But
Sir, we
currently,
have another question from Binod Bhatta. He says, which projection system do this OSM use?
I think the OSM is using Web Mercator projection system, I guess, but I'm not sure. But I think it's WGS 1984 everywhere. If you download the data, you will get it on World Geodetic System 1984. Can also be
we are very sorry to say that we have some technical issues, so please be patient till our instructor comes.
Okay, hello everyone. I think I'm back. So I just had some connection issues. So what we were doing previously was we were uh, answering your queries, right? So I can see. So are there any more queries? Who was asking them? And who was moderating it? Okay, let's look at this. Let's get back
Sir, here is a
to
question
what
for
we were
you.
discussing previously.
Hello, sir.
Okay, yeah, please.
Sir, we have a question here. How often is the satellite map of OSM updated?
Yes. Yeah. There is nothing like specific timeline or specific rule that we have about updating of those satellite images, right? So the people that they have, so OSM is a community, right? It's the open source community, and actually it is, and the satellite imagery that the OSM that we use while editing an OSM is actually provided on free of cost by different imaging services like Microsoft has Bing Maps. It provides us Bing satellite images for free, and then we have Digital Globe, and now it is called Maxar. It is like acquired by Maxar. Okay, am I audible now? I think the internet just messed with me. Okay, if you are hearing, I'm saying that deadline or something about updating of the satellite imagery, but the services are. Okay, so let me share my screen. My internet is working. I don't know about that. Okay, so let's go to this overpass turbo, and what I see on this overpass turbo is these are the different hospitals around Pokhara. So likewise, I can do what amenity equals to is that clinic, CLIC, clinic in Pokhara. I can do this analytical cleaning. So while I do that analytical cleaning, it will show me different 70 points of interest. It is now displaying what it says 70 point of interest and 19 polygons, but there are altogether 171 nodes and 19 ways. So uh, speaking about these nodes and ways, so what happens here is it's some of the features are using ways as well, right? So there are different features which are using different ways. So let's see. So this is a clinic and it is actually a way, right? So what is it doing is it is using 1, 2, 3, 4, 5, 6, 7, 8, 8 nodes. Okay, so it is a clinic and it is named as Sapana Ayurveda Hospital. And what it is doing is it is a feature and it has those tags on these outlines, right? So don't be confused between these nodes and ways. Okay, so it does not mean that there are 117 clinics, but what it means that there are 19 polygons, and along with these 19 polygons, what it is doing is there are 171 points, right? So this one polygon is representing 1, 2, 3, 4, 5, 6, 7, 8, 8 points. So it's quite misleading. But what we can do is we can download this data, right? So let's just download it. So to query this data, you just have to go over wizard, right? So you have to go on wizard your tag. So this tag is a key value pair, and the key and value are amenity, and it is clinic. Key is amenity, value is clinic, and what I'm doing is I'm searching this feature on a specific area. Okay. And my internet is not being stable. Okay. So let's download. So if we want to download this OpenStreetMap data, so what you have to do is you have to go on export and then you can download this on this. So I usually download it on as a GeoJSON file. So when I click on download, what it does is, so I previously had downloaded about 14 GeoJSON files. So it just give you export.geojson, right? So it will download as export.geojson, and if you export another, what it does is it will write the name as export16.geojson. Okay, so I can directly drag and drop this on QGIS, or what I can do is I can add, that is a vector layer, right? So that's the vector layer. I can, so on this QGIS, so there is an add layer option, right? So or you can, so this is add layer option or data source manager, and it will be there is an option to add a vector layer. And what I have to give it is I have to give a path, and I have recently downloaded it. It is export15.geojson. So when I open it and I add it to the, it will show me that there are 70 points. Now we can be sure that there are 70 points and then there are 19 polygons. Okay, so there is, so we have the data of clinics of Pokhara, right? So we have data of clinics of Pokhara city, and what we have now is we have this different data type, right? So one is on point and another is clinic. So these both are clinics, we know that, so we have to add them both. So I will select both and then I will edit. Okay, I think I have edited it twice, right? So let me just remove this. And for now, let me take both of these to the top. Yeah, the export is okay. So we have this, right? So I have downloaded the data of the data of Unix around for her, and while I can see there is this information, right? So we have a point layer, and along with point layer, what we have this polygon layer. Okay, so I will just zoom to layer, and these are the different polygons that we have. And then when I go on, what is this feature? So it will give me that it is a Chinese acupuncture center. So we have, so when we click on the attribute table, so there will be one tag, right? So there will be one tag having that key value pair that we have queried on Overpass Turbo. So it will have a one key value pair. Everyone of this feature will have the same key value pair, at least one, and it will have other different attributes of that place, right? So we have their name in Nepali, we have the name in English, we have the phone number and details, and along with that we have a lot of these different attributes and different attributes as well. So okay, so now there is one problem, right? So these are the points, and we can there is a layer, right? There is a point layer and there is a polygon layer. So what can we do? Okay, so there's a question of this. Okay, so this is these are the different words of Pokhara. So this sort of problem that usually arises when we are downloading OpenStreetMap data. Okay, so what we have is, so we have these are the same entities, right? So these are the clinics of Pokhara. So when I open the attribute table, what I can see is, so there are a lot of fields which are not necessary for now because we just want to know the name of the clinic and the contact information, right? So if we have a contact information and we already know the clinic is where, in this case we can see which is the nearest clinic of our location. So if we have a base map, and to add a base map, what you can do on this QGIS is there should be a layer tab called browser, right? So I have used these two layers, browser and layers, or you can just split it, right? So there are these two things. On if you open your QGIS, you may see like this, right? So on this layer, there is on this browser panel, right? So if you don't see this browser and layers panel, what you can do is you can go on view. Yeah, you can go on view and you can go on panels, right? And then you can click on these layers and you can click on this browser, right? So if you don't see this browser and layer panel on your window, what you can do is you can go on view, and then you can go on panel, and then you can select browser and layer. Okay, so now what I'm going to do is I'm going to use the OpenStreetMap base map on this data, right? So now what I can see is I can see OpenStreetMap, and I just dragged it on the bottom of my layers, right? So that I can see my clinics on my place. So if I am living near here, so the nearest clinic for me would be this, right? So I can see which clinics are nearer to me, like without doing any special query. Obviously, we have the option to do special query, but now these are different clinics of Pokhara. And what the problem is, if you are using your own data, or if you are using data from another source, this sort of this much of attribute data would be very, I don't know, intimidating to you, right? It would feel just what do you say? What intimidating? So you would be frightening, maybe, or you would see you would see that. So I think we have. I'll just use Nepali, right? So excuse me. So के हुने भयो त भन्दाखेरि it will be very problematic. You will see this sort of data and it will seem like problematic to you. Okay, so what you can do. So this is the case that I see when someone downloads OpenStreetMap data and then see a lot of this attribute columns and then frightens them. And then another problem that I'm seeing here is we also have few of these polygons, right? So we also have these few polygons and they are also clinics. Okay, so they are also clinics, but what we need is we also need them in as a point file, right? Because if we can overlay, these polygons are not big enough because they are actually drawn to the scale. Okay, so these polygons were drawn on the larger scale, right? So when we zoom on the map, we can actually see this place is a Chinese acupuncture center, right? So I can see his name over here. So it is a Chinese acupuncture center, and this is actually a polygon. Okay, so this polygon, when we do this, right? So when we zoom out the map in a small scale, we can see the polygon that was drawn on a ladder. So we can always see the point data, even if it is done on the larger scale. So what we need to do now is we need to convert these polygons into points, right? So that we can merge the file, right? So we can merge this and the point file, and then we can create another layer of point file. So is this clear, anyone? If you have any question, you can ask. Or you can just write on that Google Doc, okay? So what I'm talking about now is that, so whenever we download this OSM data, there arises certain type of problem, okay? So the problem being is that in OSM, we have the flexibility to tag any place as a node, right? So these places were tagged as a node, so they are actually seen as a point, right? But few objects, but the same objects can also be drawn as a polygon. Okay, so in this case, what has happened is that the polygons, they were drawn on a large scale, right? So you were digitizing this building, and in this building, it happens to be that this is also a Pokhara Cancer Care Center, and then you tag small scale map. We don't see this because this was actually drawn on a large scale. So now there is one option to do, convert this polygon into point layer. So you can do that by going to this vector, and then you can go to this geoprocessing tool. I need to search where it is. Geometry tool. Okay, so you can go on the geometry tool, and then you can use the centroid. Okay, so this centroid will actually convert your polygon, and then take all the data from the polygon into the centroid. Okay, so we have export 15. This is the way. Okay, so we also have export 15 as point, and we also have export 15 as a polygon. Okay, so geometry type is polygon, you can see. And then what we can do is we can run this file. Okay, so what it has done now is it has given us a new centroid layer. Okay, so what you can see now is we have a centroid layer, and the centroid layer is a point layer. Okay, so now what we can do is we can merge the centroid layer and this export 15 layer, and we can find now, what we can find now are the different clinics on the Pokhara city, right? So we don't need this polygon layer. So we just have now the centroid layer from the polygon, which is resulting in a point file, and then we also have the point layer of the clinics. So this this marking here, it shows that it's a temporary scratch layer. So what we can do now is we can save these two as a S3 shape file, right? So to save that object as a S3 shape file, we can export, we can save feature as, we can go to a certain place. For this case, I am using this save file, and then I will use Pokhara. What was that? Pokhara clinics point, right? So Pokhara clinics point. And then I'm using this. Someone has asked about the coordinate system, what this OSM uses. So the OSM data are usually downloaded on this WGS 84, EPSC 4326 coordinate difference system. And then just leave everything as it is and then click OK. So this is now in save file, right? So this is now in a S3 save file format. I can do the same for this centroid file. So I can save them. I think it's on the same location. Phoenix. I will use it. Centroid. Okay. So to do Pokhara Clinic Centroid, I think just as it is. And now I have this Pokhara Clinic Centroid and Pokhara Clinics point. Okay, excuse me. And then what I can do now is I can merge these two layers, right? So let me see if there is an option to merge union design geometry. Okay. Okay, yeah, merge vector layers. Okay, so what I can do now is I can merge these two vector layers. This is one is Pokhara Clinic Centroid, then there is Pokhara Clinics Point. Both of these are on the same coordinate difference system 4326. So now what I can do is I can run this, and then I will get another layer called a merge layer. So in this merge layer, so I have all of the clinics, right? All of the clinics of Pokhara city. Okay, so now I have a merged file, right? So let me go and check on the attribute table. How many clinics that we have? 89. Okay, so there are 89, and if I go on this and see, there is 70. There were 70 points, and then we also know that there are 19, 70 and 19. 70 were points, and 19 were converted centroids from the polygons. And then we have on this merge layer, what we have all those clinics of Pokhara city, right? So still we have these different unnecessary things, but they are not unnecessary. But for our case now, we don't need all of these because they are using a lot of space. What you can do is you can edit this layer. To edit this, you have to click on this toggle editing, put them yourself. This delete field option, you can delete all those things that you do not need, right? So these are the ID and ID tags from OSM. I think you also don't need them. So amenity equals to clinic. I think we all know that. So the contact number are different. There are the special clinics also. Okay, so there are from dermatology, there are from gynecology. So we keep them as it is, and we obviously need the names of the clinic. I don't know what the office means. So before deleting any field, you need to make sure that you need to know about your data very properly. Okay, so to see the data, what you can do is you can click on this. You can click on the title, and it will automatically sort your data, right? So I can see there are different fields. I don't know, this office is also only has one field. It was NGO, and then we have operator. It is also not that important. We have address. It's also not that important. Building, source, address, and all the things. So we will just delete all of this, which are not important. So in this case, what I will do, I will, I don't know why it is not. Okay. So I will click all those facilities that are not important so that so we will not be intimidated by this by the attribute table. Okay. Okay. So what I'm going to do now is I'm going to delete all these fields, so which are not significant now for us that we need. Okay. Always make sure that you are deleting those fields which you don't need now. So I will just click OK, and then it will delete one by one. And now we have something that we like, right? So we have fewer fields on our activity table, and then we can see which clinic is this, and also what you can do. So organize columns. Also, you can change the order of these columns, right? The clinic will go on last. We have the name of the clinic, name of the clinic on. Healthcare opening hours, like that. Okay, so this is how I change the layout look of this. Okay, so when you do, I will. Okay, so then I will use. Just have to click this .shp file, right? So usually a save file comes. A save file is a collection of different files, right? So there are usually minimum of two or three files, and then you have more than two or three files, right? Okay, all of these have the same name, right? So when you see all of these, .cpg, .dbf, .prg, these all have the same name, right? It is armies, npl, wgs, and then you have this admin level. Okay, so these are the same files in Nepal. It is provided by armies, I guess, and it is on WGS, World Geodetic System, Projection System, and then you have the index of the admin level, right? So uh, same file. So all of these are same name. It means this is a collection of this is a save file, right? A save file has
Hello everyone. We're really sorry for today's technical issue. Hello sir, are you there?
के भयो मेरो म जोइन भइरहेको
हजुरको गयो सर.
र मेरो गौरवको नाम सुनिरहेछ आई थिङ्क हामी अब इट्स अबाउट टाइम है इट्स 3:30 नाउ हाउ मेनी अफ यस आर हियर
भोलि गरौँला सर अब
कतिखेरबाट हो यो गम okay yes it's about time to do this tomorrow also so before that if you have any queries if you have any suggestions you can just unmute yourself and speak.
Yes, sir. We have a few questions here. Can I pursue?
Okay, so let's deal with them. Yeah, sure.
This is a question from Ali Bahadur. Okay. The first question is, can we introduce new tags and features in OSM?
New tags and features? Yes. Yes, we can introduce new tags and features in OSM. So what we have to do is we have to give them, we have to propose a new feature, new tag on OSM wiki, and then we have to get feedbacks from the community. And then when that is approved, the new tags and features will also be approved.
And another question we have here is there any way we can know the accuracy of satellite images used? Something like RMSE errors when georeferencing?
So what? So you want to georeference? I think that's a different topic, I guess. So georeferencing a satellite image or what? But that's so. What sort of error? So we don't georeference
sure about the
things on
errors,
OSM, right? Yeah.
I'm not sure. He says, is there any way we can know the accuracy of satellite images used? And he has this line here, something like RMSE errors when georeferencing. I don't know.
Accuracy of satellite images, right? So what we have in OSM is that we usually have offsets. We know the errors of offset, but I'm afraid that there is nothing like root mean square errors and other accuracies in terms of OSM data. So OSM data is a different thing, and satellite images, they are traced on the OSM data and they are different on different time intervals. So the error in that case is an offset error, but I don't know about that georeferencing thing with this.
Thank you, sir. And another question we have here is, can we perform spatial queries in the OSM image directly?
Performing spatial queries on what?
In OSM directly.
Yeah, so spatial query, I think there might be some tools, right? Some additional dashboards or some other features someone has developed that we can, like some WebGIS thing that someone has done to do spatial queries. But web, like if someone has done that, there are few people who have been developing them. There is on this, I can show, you can do routing. Let me show my screen. And so what you do, okay, so we cannot
And we have
do special query.
and says, can we?
Yes. So we can do something like this, like routing on OSM. This is one type of special query, right? But I think there are not other special queries that we can do. So you can download the data yourself and then you can do special queries using GIS. Okay, so what's the last question?
This is the last question from Vinod Bhatta, and he says, can we create TIN and DEM directly in QGIS using OSM platform?
Okay, so you can explore with team data and DEM data using OSM, right? No, using QGIS, you can explore those team and DEM data on QGIS, but OSM is a different thing, right? So OSM platform is a base map of data points, right? So you can use the data, and while you are preparing a map, you can use those team and DEM data to make your base map or to make your project more attractive. But OSM is actually a repository of those different data points, right? So it gives you those data which you want to show on your map, but that TIN and DEM are other different things. So yeah, so they are different things, and you can do that on
He
OSM
again
platform.
says, hello sir, sir, can you hear me?
Yes, I can hear you.
He again says OSM data doesn't have height data, so how?
No. So what I'm saying is OSM. What you can do is, yeah, OSM, we don't have height information on OSM, right? So OSM is just a base map, and for TIN and DEM, you just need height information. So you can download DEM from any other source, right? So OSM, you can just show those elements on top of that, right? So when you have a topographic base map, the height information is given by contours or that, what do you have? So you have contours or DMs, right? And then you have another point, and that point shows that your element is on a specific height, right? So that's how things work. So you're like,
Thank you, sir. Thank you for your answer.
okay, I'm really sorry about my network. Yeah. So apologies for my network today. I hope you guys have learned something. So we have that our Google Doc, right? And we will continue tomorrow. So over to you, Saugat or Usab.
Thank you so much, sir. We will always be grateful to see your support, courage, and suggestion for this organization. We are at the end of today's session, so I'd like to thank you all the participants for being passionate in all overall session. So thank you guys. Stay safe. See you tomorrow at 1:30 p.m.